Today we are going to start a series of aliphatic nucleophilic substitution reaction in which we in detail discuss different types of mechanisms such as SN1, SN1 prime, SN2, SN2 prime, and also see their evidences such as kinetic evidences, thermodynamic evidences. But in today's lecture we are going to see just basic concepts and general overview that what actually nucleophilic substitution reactions are and basic terms used in nucleophilic substitution reactions. So let's start. The basic terms commonly used in aliphatic nucleophilic substitution reaction are all the substitution reaction are nucleophile, electrophile, leaving group, nucleophage, and electrophage. We will discuss each in detail. Nucleophile. What is nucleophile? A nucleophile is a electron-rich species which attack on electron-deficient center or species. Means a nucleophile is basically an atom or group of atoms which have excess of electronic density, and by using its electron, it attack on electron-deficient center or an atom which have a deficiency of electron. So nucleophile, there are two possibilities. Nucleophile may be neutral or negatively charged. When it is neutral, it must have lone pair of electron. So by using its lone pair of electron, it attack on electron deficient center. Take the example of NH3, where NH3 is a neutral molecule, but here nitrogen uses its lone pair of electron to attack on electron deficient center or species. Similarly, iodine is negatively charged. NH3 is neutral, but iodine is negatively charged, and iodine uses its negative charge, the electrons of negative charge, to attack on electron deficient center or species. So what is nucleophile? Nucleophile is basically electron rich species which attack on electron deficient center or species, and nucleophile may be a neutral molecule or negatively charged. While on the other hand, electrophile is an electron deficient species, mean it has low density of electron, and our on electrophile our nucleophile attacks, mean this nucleophile attack on our electrophile. So electrophile is in most of the cases positively charged or neutral molecule. So electrophile, there are two possibilities. Electrophile may be a positively charged or neutral molecule. We will see in detail the example of electrophile and nucleophile in the coming slides. The third thing that we have is leaving group. So what is leaving group? A leaving group is actually an atom or group of atom which detach from the center before or during the reaction with or without electron pair. Mean a leaving group is generally an atom or group of atom which get detached from our reaction center before the reaction or during the reaction, and which when it get detached, it may leave with its electron pair or without its electron pair. So on the basis of whether leaving group leaves with its electron pair or without electron pair, there are two types of leaving group. One is nucleophage. If a leaving group depart with electron pair, means when a bond broken and the electrons of bond are shifted towards the leaving group or the atom of the leaving group, then it is known as nucleophage. So in such case, the leaving group bears negative charge. While electrophage, if a leaving group depart without its electron pair, then it is known as electrophage. In such situation, the leaving group has most of the cases positively charged. Now we will see what actually happened during nucleophilic substitution reaction. You can clearly understand this from this equation. Here Y is a nucleophile containing lone pair of electron. By using its lone pair of electron, it attack on our substrate. This is our substrate. Rx is our substrate. So Y is using its lone pair of electron to attack on our reaction center and form new bond with R. At the same time, the bond between R and X is broken and the electrons of this bond are shifted toward X. What actually happened? The attacking reagent, which is Y, we also called it has high electron density or electron donating power, and we name it nucleophile. Nucleophile attack on our substrate and form new bond. You can see in the product side that a new bond between R and Y is formed, and a leaving group departs. Here Y is here X is leaving group. So in this case, if we specify this leaving group, X is leaving with its electron pair. The electron of this bond are shifted toward the X. So X is leaving with its electron pair. That's why it is known as nucleophage. And here substrate has neutral charge. We can also call this substrate as electrophile. Why electrophile? Because nucleophile always attack on electrophile. By the way, this equation says nothing about charges. On the basis of charges, we can classify reaction into 4 types. As I mentioned earlier, nucleophile may be neutral or negatively charged, and Rx, which is our substrate, may be neutral or positively charged. In most of the cases, in electrophilic nucleophilic substitution reaction, we call Rx as electrophile. So there are basically four types on the basis of charges. Type 1, where our substrate is neutral while nucleophile is negatively charged, and you can clearly see that the bond between our alkyl group and iodine is broken, and bond between alkyl group and hydroxyl is formed, the alcohol is formed, and a leaving group departs. In this case, nucleophile is negatively charged, substrate is neutral, and leaving group is leaving with its electron pair. So we can call this as nucleophage. Second type, in second type, iodine leaves and NMe3 get attached with our alkyl group. So what actually happens that both of these are neutral. Our substrate is neutral, also nucleophile is neutral, and in a net result we get our product and a nucleophile. Our leaving group leaves with its electron pair. In the third type, our substrate is positively charged, nucleophile is negatively charged, and we get neutral substrate and neutral leaving group. In the fourth type, our substrate is positively charged while our nucleophile is neutral. So in all example, you can see that here nucleophile is negatively charged, here neutral, here negatively charged, here neutral. So in general, we can say that our nucleophile may be negatively charged or neutral. You can clearly see from these examples, and also that our substrate, which we also called electrophage, may be neutral or positively charged. On this basis, we have classified these into 4 types. General overview. For a nucleophilic substitution reaction, Y must have an unshared pair of electron. So by using its lone pair of electron, it attack on electron deficient species and form new bond. And we have learned in Lewis acid-base concept that a species that has lone pair of electron and it is available for the donation, and it is if it is available for donation, or if it donate it to electron deficient species, then it behave as Lewis base, or more generally saying, a Lewis base is a species that donates lone pair of electron, and Lewis acid is a species that accept lone pair of electron. So in nucleophilic substitution reaction, what actually occur there is Y donate its unshared pair of electron. So we can say that Y, that is our nucleophile, is behaving as a Lewis base. Second, if Y is the solvent, the reaction is called solvolysis. Means if the nucleophile is provided by the solvent in which the reaction is occurring, then this is known as solvolysis. Take the example of alcohol. If we want OH group in any reaction and we perform this reaction in alcohol and this alcohol provide OH group, then the required nucleophile is provided by the solvent, which is alcohol. So we can say that this process is known as solvolysis. When the required nucleophile is provided by the solvent, then this is known as solvolysis. Next, in nucleophilic substitution reaction, at an alkyl carbon is said to be alkylate the nucleophile. Means if a nucleophile get attached to the alkyl group or alkyl carbon, then it means that the nucleophile is alkylated. Means an alkyl group is added to the nucleophile. We can see from this example that here Ri is our substrate and OH is nucleophile, and this OH get attached to R. In other words, we can say that this R group get attached to OH. R group is added to OH group. We can say that this is alkylation because with our nucleophile alkyl group is attached, and we can say that this is alkylation of nucleophile. For example, in the reaction Ri and NM3 is alkylation of trimethylamine. As from this reaction you can say that here OH, here also OH group get attached to the R group, and in the net result an alkyl group is added to our nucleophile, and we say that it is alkylation of our nucleophile. Similarly, if an acyl group is carbon double bond oxygen. So if carbon double bond oxygen group is attached with our nucleophile, then it is known as acylation. In general, we can say that if alkyl group get attached to the nucleophile, then it is known as alkylation of the nucleophile, and if an acyl group get attached to the nucleophile, then it is known as acylation of the nucleophile. That is all about the basic concept and general overview of aliphatic nucleophilic substitution reaction. In the next lecture, we will discuss some basic types of the reaction or mechanism, aliphatic nucleophilic substitution reaction mechanism, and also discuss SN2 mechanism. That's all. Thank you.